Hello and welcome to this tutorial on basic statistics from Analytics School Online. Today we're going to learn about central tendencies. Now, as you already know that at Analytics School Online we first try to look at the problem so that you understand why you're learning what we are teaching. So the problem for this tutorial is this big set of numbers. Now what are these numbers? These numbers are basically 1000 data observations of heights of cars. What we are trying to do here is that we are going to try to estimate the average height of all the cars that are available in the market. But how can we do this with so many observations? So we use the central tendencies. Central tendencies come in handy when you try to represent a huge block or a huge amount of data with a single face value, and this face value actually represents your entire data. So this is the definition right here. It is basically a central location which can be used to summarize the entire huge data set, and this single value would be your potential representative for the entire data once you want to communicate this data with any of your fellow peers. So the advantages of central tendency is that it reduces mathematical and computational expenses. It reduces the time that you invest in analyzing your data, but it also comes with a disadvantage, which is that you lose the precision and information within your data. Some information in your data will definitely be lost once you try to actually convert the whole data into a single value, which is really obvious. So there are three measures of central tendency. Well, there are many, but we are going to talk about the three most common and most important. These are very influential when it comes to data analysis, so you must pay attention. These are mean, median, and mode. Basically, mean is the average, the arithmetic average of the data set. Median is the middle value, the centermost value, the value which divides the entire data set into half, and mode is the most common value that occurs in your data set. Let's look at them individually. Mean, as I already told you, is the arithmetic average of the data set. You sum your observations and divide it by the total number of observations, the total count of your observations, and bam, you can have the value of your mean. An example is given right here. You simply see that these are the observations 1, 4, 7, 3, 4, 9, 6, 7. You simply add all those values. You know that their count is 8. You divide them by 8, and 5.125 is the mean value for this data set. Moving further, just to tell you, because we're going to use this term often in the next slide, let me tell you what outliers mean. Outliers, as the name suggests, are basically extreme or unusual values that considerably do not belong to your data. They are actually odd ones if you want to understand them intuitively. They do not belong to your entire data set. They are basically values which come from errors in calculations or errors in observations, so you must keep them in mind. They can actually statistically alter the results of your data analysis, so you must be aware of them in your future endeavors. Now, well, let's look at the advantages and disadvantages of mean. Well, mean is a great tool when your data variability is not so high. So the range of values of X, or the range of observations, the minimum and maximum value, should be very short. Like, it should not range to a very vast size. It should be very small, and it can work well with both discrete and continuous data, which some of our other central tendencies don't. So keep in mind. And disadvantages is that it is greatly influenced by outliers. So if you do not handle your outliers, if you do not pre-process your data to understand outliers, you can actually be significantly affected by outliers, and that can create problems or errors in your analysis. And also it cannot be used for categorical data because it includes summation and mathematical calculations, which cannot be obviously done on categorical data unless and until you modify them and convert them into numerical data. Now, median, as I told you, is the middle value. It is the value that divides your data set into half. It is the value observed halfway throughout your data set, but there's a catch. The catch here is that your data must be arranged in an ascending manner or descending manner, in any manner, but it should be ordered in a way. And these are the basic formulas. If n is odd, the median observation is the n plus 1 by 2th observation, and if n is even, you are basically not going to get a 50% value. So what you do is that you take the average of the 49th and 51st observations, if you have 100 observations obviously in your data set. So what you do is you take the average of n by 2th and n by 2 plus 1th observation, and an example of this particular type is given here. You have 8 observations, just like the last example. You have 8 observations. So what you try to do is that you first try to order this data. That is really important, and once you've ordered this data, you need to take the average of the 4th and the fifth observation, because you have 8 observations, and by the formula of n by 2th and n by 2 plus 1th observation you get this fourth and fifth value. And so you simply take the average. 4 plus 6 is 10 and divide by 2 is 5, so 5 is the median value. You can obviously understand that arranging in ascending or descending manner would not matter, because once you arrange in any manner, what you are actually doing is that you are taking a particular observation which lies in the center, and that actually defies the mentality of actually using ascending or descending specifically. And the advantages of median: it is outlier protected because it actually considers 50%, so outliers are obviously not used in this, and it is highly suitable for non-symmetric data. What you don't know about the mean is that mean cannot be used for non-symmetric data sets. It also has a prerequisite that the data set should be fairly symmetric, but median works well with non-symmetric data sets. You can see that these are non-symmetric data sets, positively and negatively skewed. And also there are some disadvantages of median. It can again not be used for categorical data because it again involves calculation unless modified, and sometimes the median value does not give the actual central tendency of the data set, but that is very specific to certain types of data, and once you learn and grow with us you will understand where and where not to use median. Finally, mode is, as I already told you, the most frequently occurring common value in your distribution. It displays the maximum occurrence value, the value which the observation which occurs the maximum number of times in your data set. You can simply count or plot this data in a histogram, and the mode value will be the value with the maximum frequency. And the most important advantage of mode is that it can be used for both categorical and numerical data. Now this is different because we could not use categorical data in our mean and median. So this is different. Once we have categorical data, we can actually summarize them by using mode, and outlier safety is again protected just like median, because mode actually tries to calculate the maximum frequency, and the frequency of outliers is obviously minimum. The disadvantage of mode is that it most of the times does not reflect the actual center of distribution, so it is also data specific, and its existence is complex and rare in continuous data. Now what this means is that if your data is continuous, you're not going to have a larger frequency with same values, because continuous data has a lot of variety of ranges, as we learned from types of data video. So just keep in mind all of these and you're good to go with our central tendencies, mean, median and mode. There is a lot of other fun and interesting things coming up for this tutorial in basic statistics. You can learn and grow with us. See you soon. We'll be right back. Thank you.